Hi, real quick. I just wanted to talk about something I've been trying to learn, and turns out there's another abstraction that's kind of getting in my way. I kind of, I'm good with assembly, but I haven't really done a lot of Windows or Windows API stuff. I'm pretty weak with that actually. So I thought a great way to learn it, instead of just reading a lot of code, a better way would be to write some code. It's a great way to learn. So my theory was to just try to write some basic assembly that uses Windows API calls. I'll start with kind of like hello world using the message box API. I thought that was pretty simple. I did some searching online on the easiest way to do that, specifically with FASM because that's the default assembler that comes with the VM that I'm using, which is Flare from FireEye. I know assembly, but I didn't really know the FASM way to do it, so that's why I was kind of looking online. And what I saw was kind of odd. They all use this invoke kind of instruction, and they recommend it. It's the best way to do it. And I agree, it probably is the best way to do it for writing code in a more serious way. But for me, for learning what's going on in the assembly, it's kind of the worst. And it does get worse from here on out. But anyway, typically what I learned to expect from reading these API calls is you see the API call preceded by a bunch of push instructions. The push instructions are what are putting all the arguments onto the stack, and the arguments are for the message box or whatever API you're using. In this case, the invoke instruction looks a little bit cleaner and neater. You see it's invoking the message box, and then you see all the arguments following there. If I were to assemble this, I'd kind of expect the disassembly to look like a bunch of pushes, and then the message box, like a call to the message box. And finally, a call to exit process just to exit cleanly. This is what I'm expecting. So the best luck I have here is to assemble it and hope that the disassembly instructs me on how to write actual assembly. Because I would say that even though this is a .asm file, there's literally no assembly instructions in here, which is kind of bothering me so far. So I'm going to call FASM here on invoke.asm because that's the method we're using here. We're done there. I'm going to pop open a debugger so we can take a look at this. Go ahead and open this up. And I want to be on a desktop. Go to assembly. And we're going to open up invoke.exe. It's large here. I'm going to run at first, so it goes to the entry point because it breakpoints on that by default. And all the way at the bottom here, I have this message box A. This is actually a API call. When it gets to this point, this is where it's actually going to display the message box. However, where's the 4 pushes? That's kind of weird. In fact, what the hell is all of this assembly up here? This is really, really weird. I would say, to cut to the chase, this push 0 and this push 1 actually do have to do with putting some arguments on the stack. It's the whether to do the OK cancel in the case of this one, and this is like the owner thing, which we null out in all of our examples here. The only 2 things we're missing are the strings. So I don't see any pushes for strings on the stack. How the hell is this happening? It turns out that these 2 call instructions here are kind of doing that for us. You'll notice that these addresses that they're calling to are the same ranges of addresses in what we see on the screen already, meaning it's not going way off screen and you do a call routine and then you have a return. No, this is all the code we're going to run, and there's no returns. So the call is doing something a little bit different. Let's go ahead and step through this real quick. So I'm gonna step into, for all this, we push one of the stack, the one's on the stack down here, that's good. We do call to this area, which brings us all the way down here. The thing about call, when you do it, to know how to get back to where we started, in this case inc esp, it actually pushes the address of the next instruction on the stack. So when you do a return, you end up being at the instruction after the call, which is how you're supposed to do subroutines in assembly. In this case, it just pushes this address to the stack that we're never going to use to return to. Interesting. And we just do it again with this one right here. We call, and we end up down here to our last argument to push to the stack, and we push that to the stack, and now we're here. So somehow, on the stack, we actually have everything we need. Hello world, and don't click cancel. The reason for that is all this code is actually not code. It's the actual strings being disassembled by our debugger, but it's not actual code. So that's the weird trick that it used to get those strings, or the pointers to them, as arguments to message box A. So of course, if we step over this, we should get our dialog down here, which is our thing running, hello world. But I always like to disobey, cancel. And we can step and step over, and it works. But that was kind of confusing. If I'm trying to learn by sort of reverse engineering this non-assembly here, this assembly not included, so let's do it the way that I would think that is the right way to do it. Something simple like this, like yes, you have to have a data section that has our strings in it, and then you just push the arguments to the stack and you call. That sounds simple, right? Is it really that simple? In this case, the OK dialog box, the null for no owner, and our message and title. And of course, I'm pushing these arguments to the stack in reverse order because the stack being FIFO, first in, first out. So I'm going to do FASM, and I'll do the called ISM. We have that ready to go, and I'll open this up in a debugger. Let's see how one-to-one or not one-to-one this one looks. So I'm going to open it, and we're going to do the call exe version of it, and I'm going to run to the entry point. So that pretty much looks exactly like what I wrote in assembly. Of course, you don't see the strings because that's in a different area of memory just above it, but it really does seem to make sense. I mean, you just push these arguments to the stack, and we'll step over, and we see that it runs. This time we'll obey. Okay. And I'll do this one more time, and it exits gracefully. So, what the hell? However, it sounds like I'm objecting a little too much. People could argue that I'm doing this instruction a little weird. It could be simpler and easy to read, and I'll show you what I mean. I'm not just objecting because I'm mad. Like, part of it's just because it's funny. I like to be funny. So let's go ahead and actually throw in a data section here, and we'll throw in our message here, and we'll throw in our title here, pointers to it, and we'll go ahead and save that, and we'll reassemble. Let's go ahead and open this one up in the debugger. Let's skip to the entry point. And there we go. Pretty much looks the same. The only real difference is our push to 0 here, which we really don't need to exit the process. So in this case, it does actually look intelligible. Regardless, even though if I were to do it this way, which is not the initial way I saw it online I saw them inlining these fucking strings in the invoke. In fact, it was even worse than that for the title. The script that I saw online, or the program I saw online, they were invoking the command name or the command line name to be the title at the top. So like this invokeception, which made it even more abstract to me and harder to break apart. But regardless, if I lucked out and found this one, yeah, sure, it would have broken down in assembly and I could have reverse engineered from there. But altogether, that wasn't what I was looking for. I just wanted to know how to write actual fucking assembly to do the Windows API. Now, I get it. I was getting Stack Overflow answers, and when I look at Stack Overflow, they always tell me the right way to do things. Unfortunately, my luck is I don't care to do it the right way. I wanted to do it in the way where I learn the most from it. Abstractions are great. They're useful. It seems like I'm always knocking on them, but really abstractions are needed. They are useful. They make things easier. It's just the problem is if you need to understand something, say in cases where something breaks, something doesn't work the way that you expect it to, or even if you're hacking, if you need to understand how something works, abstractions don't help you there. Maybe somebody might be able to explain something to you. Maybe you'll Google something and find the answer that way. But on your own, you're not going to know the answer unless you know the lower level. And that's the kind of detail that I want to have. So when it comes to Stack Overflow answers, that's usually why they're not so helpful to me. But anyway, I thought I would share that experience with everybody.